Next we can find Laplace transform of L of e raised to at. L of e raised to at. Formula is integral 0 to infinite e raised to minus st into f of t dt. F of t here is e raised to at dt. And here we can simplify e raised to minus st into e raised to at is common power e raised to minus st plus at. There is taken this minus t outside, minus of s minus at. Okay, so integral 0 to infinite e raised to minus of s minus a t dt. Now you can integrate this. E raised to is integral is same, that is e raised to minus s minus a into t. But derivative here is minus s minus a into t, derivative is minus s minus a, and on integration we have to divide by that value by minus of s minus a and give values infinite and 0. We write in this manner infinite 0. Okay. Again we can take this value independent of t. We have to give values for t only. Then take that other values, that is 1 by minus s minus a or minus 1 by s minus a outside. That is minus 1 by s minus a into first giving the value infinite. It will be e raised to minus infinite. Okay, minus s minus a into infinity is minus infinite minus then value 0 and e raised to minus 0. Okay, 0 and it is 0, it is 1, e raised to 0 is 1. Then answer is 0 minus 1 here and multiply by minus 1 by s minus a. Answer is 1 by s minus a. Okay. This is the Laplace transform of e raised to at. Find the Laplace transform of e raised to at. Then this is the method. Okay. Or find the Laplace transform of e raised to minus 3t is the question. Then what to do? L of e raised to formula is integral 0 to infinite e raised to minus st into f of t, that is e raised to minus 3t dt. Again that is integral 0 to infinite, simplifying this e raised to minus of s plus 3t dt. Okay, and what is integral e raised to minus s plus 3t by minus s plus 3 and giving values 0 infinite. What happens? We can take this minus 1 by s plus 3 outside, and after giving these values, what happens? E raised to minus infinite, that is 0, and e raised to 0, that is 1. Multiplying, we are getting 1 by s plus 3. Okay, this is a method to find the Laplace transform. And next we can find the Laplace transform in general of what is L of t raised to n. This can be done by a method that is discussed in your note. See the notes values. And again next we have to find the Laplace transform of cos kt, sin kt, etc. standard forms. For that we use linearity. Linearity of Laplace transform is L of some constant into a function alpha into f of t plus another constant beta into g of t. Hence Laplace transform can be found out by taking this constant outside, alpha into L of f of t plus beta into L of g of t. This is a linearity property of Laplace transform. For finding Laplace transform, we can take the constants outside and the sum of two functions Laplace transform is taken as independent, L of first function plus L of second function. This is the case here if it is minus also. Okay, this is the property, linearity property of Laplace transforms. Next we are going to find what is the Laplace transform of sin kt, cos kt, standard forms. For that we consider a result that is e raised to, we have e raised to I theta, e raised to I theta is equal to cos theta plus I sin theta. That is a result. Then what is e raised to I kt? Instead of theta, we are taking kt. That is cos kt plus I sin kt. And we know Laplace transform of e raised to I kt. L of e raised to I kt is equal to, here it is L of cos kt plus I into linearity, using the linearity of Laplace transform, I into sin kt. But what is L of e raised to I kt? We know e raised to at is equal to 1 by s minus a. L of e raised to at, you have the result L of e raised to at is equal to 1 by s minus a. Likewise, here a is ik, e raised to at ik. Let's see, transform is 1 by s minus a, s minus ik, equal to this same. But we can simplify this s minus I, it is a complex number, by multiplying it by its conjugate on numerator and denominator. That is, we are multiplying by s plus ik in the numerator and denominator. S minus ik into s plus ik. What is its value? A plus b into a minus b is a square. Denominator is a square minus b square, ik square. Ik square is I square k square. But I square is minus 1. I equal to root minus 1. You know, I square is minus 1. Minus 1 into k square. Numerator is s plus ik. Denominator is s square plus k square. Splitting up. S by s square plus k square. Dividing this s by s square plus k square, plus again dividing k by this, plus I into k by s square plus k square. Okay. And left side is L of cos kt plus I into L of sin kt. Comparing both sides, real and imaginary parts, L of cos t is equal to s by s square plus k square. L of cos kt is equal to s by s square plus k square. Similarly, L of sin kt, k by s square plus k square. This is a standard result. Okay. If there is a question that write the Laplace transform of cos 5t. Write means you know to find. You need not find the value. Write Laplace transform of cos 5t. Then it is like cos kt, k equal to 5. Then s by s square plus k square, that is 5 square, 25. It's answer. Or the question is, this is a question to that write Laplace transform of cos 5t. That is, we know for Laplace transform of cos kt is s by s square plus k square. And just writing L of cos 5t, instead of k we have 5 here. Then s by s square plus k square, that is s by s square plus 5 square, that is 25. It's answer. Or if the question is find Laplace transform of cos 5t, then we have to find it either by using this method, that is e raised to I 5t. First we start with e raised to I 5t is equal to cos 5t plus I sin 5t. And as above, take Laplace transform here and here. And here it will be e raised to at and 1 by s minus a. It is 1 by s minus 5i. And here is L, psi into L of sin. And as in the above case, simplify it by multiplying by conjugate s plus 5i, numerator and denominator, and simplifying. You will get L of cos 5t as a real part here, and L of sin 5t as an imaginary part. Okay. We are asked to find only Laplace transform of cos 5t. This is a simple method. or you can directly find the Laplace transform by using the formula, that is L of cos 5t. What is the formula? Integral 0 to infinite e raised to minus st into cos 5t dt. Okay. Suppose this is some value I. Then how can you find I? I is equal to this value. That is L of cos 5t. So definition. Integral 0 to infinity e raised to minus st into f of t. F of t is cos 5t dt. We are taking this value of integral as I. That is I is equal to L of cos 5t. Now how you can find using product rule of integration? That is first function as e raised to minus st and second function as cos 5t. Or conversely, you can take first function as cos 5t or second as anyway. Suppose we are taking first function as cos 5t. Suppose. Then first this, second this. That is cos 5t. First function into integral of second is e raised to minus st by minus s, giving values 0 infinite. Minus integral 0 infinite. Derivative of first function, that is cos 5t. Derivative is minus 5 sin 5t. Okay. Cos 5t derivative is minus sin 5t, and 5t derivative 5 multiplying minus 5 sin 5t. The integral of second is same, e raised to minus st by minus s dt. Okay. Again, you can simplify here. First one, I is equal to minus 1 by s outside, and e raised to minus infinity is 0. E raised to 0 is 1, but cos 0 is also 1. Okay. Cos 0, cos 5 into t, cos 0, 1 ആണ്. E raised to 0, 1 ആണ്. അപ്പോൾ ഇങ്ങനെ വരും. Okay. Here we can take this 5 by s outside plus 5 by s outside, minus 5 by s outside, and the integral 0 to infinite sin 5t into e raised to minus st dt. Okay. Again integrating, here it is I is equal to 1 by s. Here it is 1 by s minus 5 by s. Again integration, first function sin 5t into integral of second is e raised to minus st by minus s, giving values 0 infinite, minus integral of derivative of first sin 5t, derivative is 5 cos 5t into integral is e raised to minus st by minus s dt. Okay. That is I is equal to 1 by s minus 5 by s into, for this minus 1 by s outside, and again e raised to minus infinity, first value is 0, and sin 0 is 0, e raised to 0, 1, 0, vanishes both the limits, and here we can take plus here 5 by s outside, integral 0 to infinite e raised to minus st into cos 5t dt. Okay. But this is I. E raised to minus st into cos 5t is I. Okay. Therefore, you can write I is equal to, we have started from I, 1 by s minus 5 by s into, here it is 0, 5 by s into I, here, I. That is again we have I is equal to 1 by s minus, here it is 25 by s square I. Take this I to one side, 1 plus 25 by s square I is equal to 1 by s. What is I? I is equal to 1 by s into s square by s square plus 25. That is equal to s by s square plus 25. This is a method to find Laplace transform of cos 5t using the definition. Okay. Find the Laplace transform of cos 5t. Then answer must be like this. To find it, not simply writing the formula L of cos 5t, cos kt is equal to s by s square plus k square, and replacing k by 5. That is the easy method, but that is question is if it to find, then we have to find it by either by using the formula or by the method e raised to I 5t equal to cos 5t plus I sin 5t, and taking Laplace transform on both sides and finding the value. Okay, thank you.